Hi guys, in this video we will be looking at MIP 2602 question 2 and 3. Right, if you are new to this channel, what are you waiting for? Kindly subscribe. You only subscribe once, right? We are at 950 subscribers. We're still gonna need more 50 subscribers, guys. Let's make it happen by sharing the video and encouraging others to subscribe. That will be highly appreciated, right? Without wasting time, let's get to today's video. Question 2. A chemistry student conducted an experiment and discovered that her report contained an error. We know an error is a mistake, right? She recorded the following data: 5,8, 7,4, 6,2, 60, 7,4, 5,9, 8,3, and 7,3. Use the data provided by the data provided by the chemistry student and answer the following questions. 2.1.1, determine the mean or determine the mean. That's 2 marks. Well, guys, my advice is that first, this is an ungrouped data. First, group it from ascending order to descending order. So without wasting time, let's put that into practice. We will start with the mean, then followed by the median, then the mode, and so on and so on. Right? That's how it should be. That's how, guys, right? Let's put that into practice. Well, as 2.1, remember it's question 2, 2.1.1. We need to find the mean. But first, let's group the data. That will be 5,8, 5,9, 6,2, right? 7,3 and 7,4 repeats itself. 7,4. Okay, we also have 8,3. Then the biggest number, it's 60. So remember, it's from ascending to descending, right? From the smallest to the highest. So in this manner, we need to find the mean. The mean, it's sum of data, guys. Sum of data, meaning the total of these numbers divided by the number of data. So the reports were 8. If you can count from these numbers, you can see that their reports were 8. So what I'm going to do with you guys is to add these numbers. Let's add 5,8 plus 5,9 plus 6,2 plus 7,3 plus 7,7, plus 7,4 plus 7,4 plus 8,3 plus 60. So when you add all of these numbers, you are going to have 108,3, then divided. Remember, 108 is the total number of this, the sum of this, then divided by 8, the number of reports that were conducted. So we will say 108,3 divided by 8. What is that? We get 13,537. Oh, 8. Yes, it's correct to 2 decimal places if you're using your calculator. So remember, using a calculator, this will be 13, 538. Yes, in this case, it will be 538. Right? So that's the solution there at 2.2.1. Then the second question requires us to find the median. The median is a middle value on a data set. So what am I going to do? Since we have 8, I will count 4. 1, 2, 3, 4. Okay. Set 1, 2, 3, 4. Yes, and just put a dot here. Let's go again. 1, 2. This is 8.3. Don't forget, it's not 83. It's 8,3. So it's gonna be 1, 2, 3, 4. So we're also gonna put this. So meaning that the median will be between 7,3 and 7,4. So to find the median, you ought to do this. So 7,3 plus 7,4 divided by 2. 7,3 plus 7,4 divided by 2. What is that? Remember, they said we need to leave our answer correct to 3 decimal places according to our instructions. That's 7,350. All right, 7,350. We have calculated the median. Then they said mode. What is the mode? A mode in a data set, guys, it's a number that appears frequent, or the number that appears the most. If you can see from this data set, 7,4 appeared twice. So that makes it a mode. Remember, a mode, it's a frequent number, or the number that appears the most in the data set, right? So in this case, it's going to be 7,4. We are on a right track. Now we are going to 2.4. At 2.4, they said determine the first quartile. The first quartile. Well, the first quartile, guys, remember you have 8. What is the quarter of 8? You say 1/4 times the first quartile. 1/4 times 8, meaning the second number, that will be 2. The second number will be our first quarter. But remember, we did find Q2 here, which was our median, aka median. Then what numbers were left there? We're left with 1, 2, 3. No? Remember, I told you that the quarter of 8, that will be 2. So meaning that this is 1, 2. This will be 5,9 will be Q1, right? Let's also find the third quartile. For the third quartile, you are going to say 3 divided by 4 multiplied by 8. What is that? The 60 number. So let's count from here. It's 1, 2, 3, 4, 5, 6. Okay, it's 1, 2, 3, 4, 5, 6. So meaning that 7,4 will be our third quartile. Even if you, let's see, did I did it correctly? 1, 2, 3, 4, 5, 6, 7, 8. Right? So it's 1, 2, 3. It's 1, 2. It's 1, 2. We're left here, as well as okay. Even if I were to do this, we're left with 3 numbers here. 1, 2, 3. So there will be 1. Oh, 2. Yes. And I think I'm in the right position. Because we need to recheck before you do this. You must do it correctly. Well, let me verify, guys, again, so that I'm in the right track. Remember, where it is 7,3 and 7,4, this is where we did find our Q2, right? We did find our Q2. So it is very essential for us to work out this in an orderly manner. So what remember, there were 8 numbers: 1, 2, 3, 4, 5, 6, 7, 8. So since there were 8, we said 1, 2, 3, 4. We put a dot. Then 1, 2, 3, 4. 1, 2, 3, 4. You put a dot. Between the 2 numbers, we got Q2. No? So how many numbers were left from the left? It's 1, 2, 3. So what did we do? We counted 1, 2, 3. So the middle number, that was our first quartile. Then similarly, what numbers were you left with here? We were left with 1, 2, 3. So we are going to say 1, 2. So meaning that this should be our Q3. Yes, now I've verified 8,3 will be our Q3. So at 2.4, they said determine the first quartile. The first quartile is Q1. You'll write first quartile, which will be 5,9. Then at 2.1.5, the third quartile, which is Q3. The third quartile will be 8,3. Then they said at 2.1.6, determine the standard deviation, guys. I mean, determine the variancy. They wanted the variancy. He said determine the variancy. Then the variance, guys, will be the square root of a standard deviation will be SD, which is equals to the square root of standard deviation. Then we'll go on at 2.7 and 2.8 and until 2.1.11. Let's put that into practice. So in this case, 2.1.6 SD will be the square root of variancy. Actual variance is the square root of standard deviation. So in other words, what does that mean? In other words, it means that I need to punch this in a calculator. Put it in a calculator. I'll press 2. I'll say, if you're using a Casio, just say mode setup, press 2, then press one variable. So we start with 5,8, 5,9, 6,2, then 7,3, then 7,4. Remember, it repeats itself, 7,4, then 8,3, then the biggest number, 60. Then you press AC, shift, then there's a button stats. Then remember, we're looking for a standard deviation. That will be 4. You press 4. How many numbers are here? 8. That's correct. Then shift again. Where there is 3, it's our standard deviation. 3, it's our standard deviation. So remember, variance, since it's a square root of a standard deviation, you are going to take this root. You take this answer here. So in other words, this will be our variance. Remember, variance is a square root of a standard deviation. So I'll take the standard deviation, 17,580. So what is my variance? My variance will be 4,193. 4,193 will be, remember they said correct to 3 decimal places. Let's move 2.1.7. Determine the interquartile range. The interquartile range, which is IQR, will be the difference between the third quartile minus the lower quartile or the first quartile. So in other words, it will be 8,3 minus 5,9. 8,3 minus 5,9. What is that? That's 2,400. Correct to 3 decimal places, right, guys? So we now move to 1.2.8. We are not done. You go back here, shift, mode setup, shift, stat, then variable 4, standard deviation, it's 3. So that's the standard deviation, 17,580. Then SD, our SD, it's 17,580 standard deviation, right? And we go to 2.1.9. Then do the data contain an outlier? To prove that we could contain an outlier, we are going to say the first quartile minus 1,5 times IQR, meaning this is for the smallest quartile. So you are going to take your lower quartile. Remember, your lower quartile, guys, was we did calculate, it was 5,9. This is gonna be 5,9 minus 1,5 times IQR. Our IQR was 2,400. Then what will be, this will be 2,3. So this the lower outlier will be 2,3. So let's go for the one that is greater, Q1 plus 1,5 multiplied by IQR. Yeah, these are expressions that can help us to find an outlier in a data set. Remember, an outlier is that value that can be smaller or greater than the other values in a data set, right? So we have remember here we're gonna use Q3, not Q1.
For Q3, remember what did we get there? We get 8,3, so it's going to be 8,3 plus 1 plus 1,5 multiplied by 2,400. Then I'm going to have 11,9. 11,9. So meaning that your outliers must lie between 2,3 and 11,9. So in this case, guys, if we can check our data set, which we have a value that is greater. The value that is greater is what? Is 60. So meaning that 60 is our outlier. It does contain an outlier, meaning a 2.1.9. Yes, we do have. Do the data contain an outlier? Yes. 60 is an outlier. So, but you must also show this step must be written as well here. First show this step, then your right hand 60, it's an outlier. So that's how you would have achieved the desired goal, right? That's how you should have achieved the desired goal. So I hope, guys, I'm making sense. Now we are going to 2.1.10. Then they said, which of the following central location will best summarize the data in 2.1? Give reason for your answer. Which of the measurements of central location will best summarize the data in 2.1? Give reason for your answer. Well, for 2.1.10, that will be mean. Why I say mean, guys, it is because the data contain an outlier of 60. So in this case, at 2.1.10, you will say it's a mean because the data contain an outlier of 60. Then you get that beautiful 2 marks. Then at 2.1.11, which of the measures of deception spread will summarize the data in 2.1? Give reason for your answer. Well, in this case, guys, IQR, which is the interquartile range, it is less affected by the outlier as compared to the variancy and standard deviation. So it will be IQR in this case at 2.11. So that's how it should be, guys, at 2.11. Now, I will want us to delve into another thing. We are going to look at the group data then now at 2.2. So we are going to look at the group data. Let's work on it. A school raised funds for a charity by selling tickets to show. The number of tickets sold by 24 volunteers was recorded in the table below. So then they said the school would like to analyze the tickets using the data provided. Complete the table below. So we'll need to complete this and get this beautiful 12 marks. How are we going to do that? We have an interval of 10 is to 20. How many that are there from 10 to 20, guys? If you can count, we have 16 1, 18 2, 17 3, then 18 4, then 12 5, then 19 6, then 14 7. So there are 7. So we are going to put 7 here at the frequency. Then let's go to those from 20 to that range from 20 to 30. How many are they? Let's calculate. We have 1. We have 1. We also have 2. We also have 3. We also have 4. We also have 5. We also have 6. We also have 7. We also have 8. We also have 9, 10, then 11. So meaning that here it's going to be 11. But let's put that into practice. Well, let me just draw this table. Yeah, yours will be accurate, guys. You will forgive me. Yours will be accurate. Then here it's intervals of tickets. Interval of tickets. Then we have 10. We also have 20 and 30. So we are also gonna have 30 and 40. Yes, just to add from the one that is missing. Okay, so we have frequency. Remember, so those that range from 10 to 20, we said it's 7. Those that range from 20 to to 30, we said it's 11. Those that range from 30 to 40, we said it's gonna be 6, right? Then the table is huge. We also have a relative frequency here. Relative frequency. Oh, but they said in percentage. Let me just put percentage, the symbol. Then we also have cumulative frequency. I'll say CMF, also must be in percentage. So what are we going to do? Well, we need to find the relative frequency here. To find the relative frequency, guys, let's find the total here. Remember, this table, yours must be neat, not ugly like mine. This is the total here. So let's see how many are those that will be able to, the number of tickets sold by 24 volunteers. Let's see. How many are they? If you say 7 plus 11 plus 6, that's 24. It's also given in the statement. So that's 24. For us to find the relative frequency, we are going to say frequency divided by the total number of volunteers, multiply by 100. Multiply by 100. Let's punch the calculator. We get 29,17. Then also 11 divided by 24 times 100. What do we get? 11 all over 24 times 100. We get 45,83. 45,83. That's 45,83. Then we also have 6 divided by 24 times 100. What do we get? What do we get? We get 25. We get 25 here. So to find the cumulative frequency percentage here, remember, you're going to take this 29,7% and add this 29,7% with 45,83. So in other words, you're going to say 29,17 plus 45,83. What is that? That's 75. So meaning that I'm going to have 75% here, guys. So from there, I'm going to say 75 plus 25, I'm going to have 100%. Going to have 100%, isn't it? So if I add this to find the total, 17, if I say 29,17 plus 45,83 plus 25, I'm getting 100% as well as here, it's going to be 100%. Yes, so it's going to be 100%. Then 100% there is simple. 100%, we have 100% there. So that's how you would have calculated that beautiful 12 marks. I hope, guys, it does make sense, right? Then we have 2.2.1. Let's put that into practice. Let's see what the question requires. At 2.2.1, they said, what percentage of volunteers sold fewer than 30 tickets? What percentage of volunteers sold fewer than 30 tickets? We can see from our table we got 75. Those that sold from 30, that sold less than 30 were 75%. So that will be the percentage. Then they said we need to draw a stem and leaf. Then after 2.2, add the data symmetrically positively skewed. Give reason for your answer. Well, at 2.2.1, we said that's going to be 75% of those people who sold fewer than 30 tickets, meaning they are in this interval, 20s to 30, which is 75, right? So we have, that was 2.2.1. 2.2.1.2, draw a stem and leaf. So you're going to have stem and leaf. Regarding the numbers that we are having, they end at 3, so we are going to put 1. We're also going to put 2 and 3. If you go back to your data here, guys, we need to check. 1 goes with, we also have 12 and blah blah blah. So let's put that into practice. If you check to your data there, we have 2, we have 4, we have 12, we have 14, we have 16, we have 17, we have 18, we have 18, we have 19. At 2 we have 20, we have 22, we have 23, we have 24, 25, also have 25, also have 25. Yes, also have 25. I'm still checking. Yes, we have 3 25s there. We also have 6, we also have 9, also have 9. Then let's go to the 3s. Remember, it's 12, it's 14, it's 16, it's 17, and so on and so on. It's 20, it's 22. So in terms of 30s, we have 32, we have 33, we have 35, we have 38, we also have 38, we also have 39. So that's how you will have draw your stem and leaf. That's how you plot a stem and leaf. So you will get that beautiful 4 marks. I hope, guys, that sounds great. 2.2.2. Are the data symmetrically positively skewed or negatively skewed? In this case, if we were to prove it with a mean and a median, I will say it's positively skewed. So in this case, it will be positively skewed. That's my conclusion. Positively skewed. It will be positively skewed because why? More values are clustered or they dominate. They are clustered on lower side, on our lower side, which is 10 and 30. And another reason could be the values lie between 38 and 39, causes these to move to the right. Is values that lies between 38 and 9. That will be another reason. Then we get that beautiful 45 marks, guys. I hope I've made sense in making you to get that 45 marks right. You just have to listen and put this into practice. Let's go to question 3 now. Okay, right. At number 3, based on question 3.1 to question 3 to 3.6 are based on the following information. The table it's a summary of the energy source used for cooking. Suppose you pick a house at random from the list of South African residents. So we are given the provinces as well as the energy sources. So we have electricity, paraffin, wood, and coal. What is the probability that the household will be what is the probability that the household that will be a wood and a coal user? Well, in this case, guys, we are given the total. Yes, remember, probability, it's a number of possible outcomes divided by the total number. The total number is 8864. So as for the wood and coal user, we go here. What is the total? It will be 1667 divided by this overall total, right? So at 3.1, you are going to say for wood and coal, this will be the total for wood and coal. That will be the possible outcomes is 1607 divided by 8864, which is the total number of data, the total number that is given them. So we have 1667 divided by 8864. That will be in 3 decimal place. That will be 0,189. So approximately when we times by that 100, we get correct to 1 deciplace. That will be 18.8%. Hope that makes sense at 3.1. Then let's go to 3.2. At 3.2, they said, what is the probability that the household will be from Free State? Well, they said from Free State. Let's go to Free State, guys. From Free State, where is Free State? Looking at Free State, what are we having from Free State? The total is 696. So the Free State part, we are going to use that total 696 and divide it by the overall, which is 8864, to get the probability. So Free State, probability of Free State that the household will be from Free State, we said is 696 divided by 88464. So we are going to say 696 using our calculator, 64, then correct to 3 deciplace, that will be 0,079, which is approximately in 1 deciplace, that will be 7.9%. That's how it should be. That's the probability at 3.2. Let's go to 3.3. At 3.3, they said, what is the probability that the household will be from Limpopo or Mpumalanga? When they say from Limpopo and Mpumalanga, we will add the totals. Let's go to Limpopo and Mpumalanga. Limpopo, it's 989. In Mpumalanga, it's 737. So we're going to say 989 plus 737 and divide it by 8864. So we get our probability. Probability of Limpopo or Mpumalanga. We said it's going to be 989 plus 737 divided by 8864. Let's punch our calculator. 989 plus 737 divided by 8864. What is that? In correct with 3 deciplaces, that will be 0.94. So which is approximately in percentage. In percentage, that will be 19.5%. That will be our probability, right? So we go to 3.4. At 3.4, guys, they said, what is the probability that the household use coal as a source of energy or will be from KwaZulu-Natal? Well, guys, the household use coal, and we're being told that it use coal. It use wood and coal as a source of energy, and is from or will be from KwaZulu-Natal. So if we go to coal and wood, we know that the total for this is 1667, right? So you will write that household coal and wood will be 1667. Then let's look at KZN. For KZN, the total will be 15 and 94, 1594. Then we are not done. If they use coal, we also have wood and coal in KZN. That will be 520. So let me show you using a calculator how you can get the probability here. No? First thing first, they said 1,607 wood and coal. Then secondly, in KwaZulu-Natal, the total will be 15,904. Plus we also have wood and coal in KZN. Let's subtract with that 520. What are we getting? We're getting 2741. 2741, then you are going to say 2741 divided by 88 divided by 88,664. What is that? This is the probability. In decimal places, it's going to be 0,309. You write it in percentage times by 100. That will be, in one decimal place, that will be 80.9%. That's how you will have calculated 3.4. Then let's go to 3.5. For 3.5, they said, what is the probability that the household will be from Free State and Northern Cape if two households were picked one after the other with replacement? If it's with replacement, that is an independent event. What are we going to do? So remember, we are being told that what is the probability that the household will be from Free State and Northern Cape? And means multiply. So in probability, and means multiply. So let's go to Free State. At Free State, we had 696. At Northern Cape, we had 229. So I'm going to take my calculator again. 696 divided by the total, which is 8864, multiply by, at the Northern Cape, the total was 229 divided by 864. What is the probability? All right, if you change this in decimal, that will be 0,2, this will be 0,203%. Yes, that will be the solution at 3 with replacement 3.5, right? So let's go to 3.6. Well, at 3.6, they said, what is the probability that the household will be bought from Northwest? That the household will be bought from Northwest if two households were picked one after the other without replacement. That will be a dependent variable. So if the first one, let's go to Northwest. Northwest, where is Northwest? Northwest is 571 divided by 8864. Because without replacement, meaning when they say without replacement, you're going to, for the second outcome, second probability, you're going to subtract this by 1. So it will be now 8863. So let me show you using a calculator. We said that will be for Northwest 571 divided by the overall, which is 8864. So without replacement, you subtract the numerator by 1. You're also going to subtract the denominator. So it's going to be 8863. Sorry for that. So this will be the solution. So if you change this into decimals, this will be 0,414%. So that's how you're going to work out this probability. That's how you're going to get that beautiful 18 marks. Hope you did understand question 2 and question 3. Do not forget to subscribe and like, comment, and remember, wishing you all the best for tomorrow. We love you.